Welcome to another video. In this video, I'm going to talk about Pig installation process and running Pig in basically managing big data. This is very important topic. Apache Pig operates as a client-side application, meaning it can interact with the Hadoop cluster without requiring any additional installation on cluster node. Pig submits job and communicate with the HDFS directly from the local machine. Installation steps. So first we have to go through their official website and we have to download Apache Pig and then unpack the tarball. In that tar xyf pig hyphen x dot y dot z dot tar dot gz. It's a zip file, and then hyphen c root directory tilde sw slash. This actually extract into this particular place, okay, and replace xyz with the actual version. This is what version you are downloading, correct? Setting environment variable. In this step, basically, while installation only, we will get the option for setting the environment variable for the path. We have to just take, otherwise add pig bin directory to path, export pig home, and in that particular place. And this is what the particular version. Export path dollar path column dollar pig home bin. Ensure Java home is set to your Java installation. In all the way, we are always required the Java home, right? Export Java home and the particular path. And for example, in the user, in the root directory, user folder, in that lib folder, inside that Java virtual machine folder, inside that the particular JDK. Java development kit is there. Verify installation. Then we have to verify that by using hyphen help on our command prompt and display uses of instructions and running pig. How we can run pig? In two mode, I think we can run it. One is a local mode, another one is MapReduce mode. Local mode like pig hyphen x local and MapReduce, pig hyphen x and MapReduce. Once installed, you can start writing and executing pig Latin script to process large data set efficiently. Execution type. So here you have seen in how many types of a running mode of pig, local mode and MapReduce pig, and for that mode, and for that you have seen that this what you can say the commands. Next, execution types. There are three types of execution of a pig, and to process the data through these modes, depending on the use of clusters and case, right? So local mode. First is local mode. In the single JVM, access local file system. In that, a small data set will be there and testing pig script, enabling using like through local mode, right? Next is, and here we are working with the grunt shell for interactive execution of programs. MapReduce mode, default execution mode. This is actually default execution mode. Here, translate big Latin script into MapReduce job and run them. Hadoop cluster require Hadoop compatibility. Check pig Hadoop version and configuration like Hadoop underscore home match cluster Hadoop version. Configure cluster settings. These are the steps we have to follow to execute the pig Latin, right? Then Hadoop configuration directory pig.property run with this command are just pig by default. Okay. Performance optimized mode. This is another mode, performance optimized mode. In that, Apache Tej and Spark mode for faster execution of MapReduce recommended if available in newer pig version. And one more, that auto local mode. This is optimization for a small job, less than 100 MB and less than one reducer. Enabled by setting in pig properties. Pig.auto.local.enable true, pig.auto.local input max bytes, run job locally instead of on the cluster. Use local mode for testing, MapReduce mode for large scale processing. Configure Hadoop cluster setting properly for MapReduce mode. Tej Spark mode, if improve performance, auto local mode is optimized small job execution. Running Pig program. So Apache Pig support three execution method application in both local and MapReduce modes. So let's see. For short script, use the -e, pig -e, and double inverted code A equals to load. Inside that, we will pass the string like data.txt, which file, and the dump A. Use case ideal for production workflow and reuse script. Second is grunt script mode. It is a script mode, right? We are running in a script mode. Next is grunt interactive shell. And for script mode, remember this pig.script.pig, you will use this command. Grunt shell and grunt interactive shell is very popular interactive shell where we are launching and running without a script or -e option, right? So pig -x local and pig, you are running it. The run script.pig execute script in the current version. Exec script.pig runs script on new version. Here debugging and prototyping is available. Embedded mode. When Pig in Java application like Pig server, similar to JDBC for SQL and Pig runner for programmatic grunt access. Right? Pig server, Pig new Pig server, exec type dot local, Pig's register query, a load input txt using Pig storage, right? So what are the differences we'll see here? If you're in scripting mode, this is useful for batch file command and production job. And interactive shell grunt, and this is useful for debugging and ad hoc queries. And when embedded, Java API and custom application. So here some tricks are given. Script mode automated workflow, grunt is interactive exploration, and embedded mode is rare but useful for Java-based extensions. Few more overview on a grunt. Possibly you can go through this. Grunt is a pig interactive command line shell allowing users to execute pig lighting command interactively, debug script step by step, test data processing logic without full script, line editing features, cursor like control A, and command history, control P, control N, and their process is mentioned here. Just observe this, what they are doing. Previous command, next command, or up, down you want to do, or ending line, or a start of line you want to move. Tab completion, auto complete big Latin keyword like typing GE plus tab, generate, and custom completion at user defined function or file path via auto complete file. File format one token per line. Location pick conf directory. Help or session management. View command uh, or exit grunt like quit or /q. Example grunt session. Grunt data load particular file using pig storage, loaded data, filtered, right? And dump display and exit. Command history, navigate past command, smart completion, tab complete keyword, interactive debugging, test each step before full script execution. Session control, help for command. So use Grunt for rapid prototyping of a pig script, leverage tab completion to avoid syntax error, customize autocomplete for frequently used path. Grunt does not support file name autocompletion for HDFS path. Pig Latin editor syntax highlighters. However, for Eclipse, IntelliJ IDEA, Vim, Emacs, TextMate, like these are the few famous editor. Where who web-based big script editor in many Hadoop distribution. For example, max temperature by year. Pig Latin script will take the max temp dot pig load data year temperature quality record load input and ctc. You have taken this data from National Climate Data Center, micro tab, like it's in a sample txt format as alias. You are using alias here as year char array, and you're defining the year is which data type, temperature is what data type, and quality of that particular in the particular data type here. Year is a char array and character array, and temperature is integer, quality is integer. Filtered invalid record, missing temp, bad quality. So filtered record by temperature not equals to 9999, and quality in 01459, like that. Group by year, group record, group filtered record by year, by is alias. Calculate max temp per year, max temp for each group record, generate group as year, max filtered record dot temperature as max temp. Output dump max temp. So key steps what we had gone through: loading, filtering, grouping, for each generate, interactive grunt session, inspect data, and debug, right? Test each step, like. And so load is read data with schema, and filter means remove invalid record, and group by like aggregate tuple by key for each generate, transform, and aggregate. Replace sample.txt with HDFS path, HDFS column triple slash input slash for cluster execution, generate example for illustrate operation. So these are the things you have to follow, and this type of output will come, right? So you can see here very well defined loading, record, and grouped, how these are working, right? So just observe this, and you will come to know how result are produced from the larger data set in this way, right? So you can say year is 1949 and the temperature is 78 Fahrenheit and quality is 1. Okay. Advantage over random sampling, illustrate guarantees coverage of a query, big specific random sampling, simple to implement, may yield empty result. So comparison with database, Pig versus SQL, Pig data flow declarative, constraint defined, right? Schema flexibility, data structure. Their SQL is using basically flat table, no? But Pig is having nested like back tuple maps, like that. Performance batch processing by Pig, but SQL optimized low latency. Customization, Pig user-defined function, and streaming deeply integrated. SQL having limited and built-in functions. Hybrids, so uses SQL like syntax, HiveQL, but store data in HDFS like Pig. Use Pig flexible large scale ETL. Use SQL RDMS in the transaction low latency. Now Apache Pig Latin. Basically high level language for processing large data set on Hadoop. And this is very important topic, Apache Pig Latin. And that abstraction converts big Latin script into MapReduce, the Spark job, which cases ETL data analysis and iterative processing. Execution mode, same local, and MapReduce mode, and Tej Spark node. Okay. And default mode is MapReduce mode. Tej Spark reduce latency by optimizing tag execution, direct acyclic graph. So data types like atomic data type, int, long, float, character array, boolean. So and their descriptions, complex type like tuple, bag, and map. Right? I hope this is all clear with you all. Byte array and date time. Schema handling. Schema and defining a schema, explicit schema, and schema validation, and schema merging. These are things: load, store, dump. So these are the things given. Load for read data, store for save data, and dump for print to console. Data processing filter for each group join. So remove rows filter for each transform field, and group aggregate by key, and combine relation by join. Apart from that, distinct, F distinct, removing duplicate. So diagnostic operators: describe, explain, and illustrative, right? These are three. And functions, built-in functions like eval, filter, and load store. We have a evaluation function, filter function, load and store function. So total 4 function. User-defined functions like custom functions, extend pig with Java and Python. Example register my udf.jar, define my udf. This is all the way to declare the user-defined function in this, right? Keep in mind advanced features like macros. Macros means reusable pig Latin snippet, which we are declaring globally. H catalog integration and multi-query execution. Best practice performance: use algebraic function like sum, count, max, leverage combiners, filters early, reduce data volume as a with filter, schema enforcement, define type to avoid byte array overhead. So if error handling a bad data, so good equal to filter data by temperature and not equal to 999, and bad filter data by temperature equal to 4 times 9. This is what you can differentiate the data by giving command. Debugging, describe data, check schema, sample, illustrate data. Example, here example listed out. And then till now we have studied a lot more things. So the quick references given here. And so we came to know these all the things is required in Pig Latin, Apache Pig Latin, which is high level data processing language. So go through this all notes, you will get a lot more idea. So one more topic is here, very important topic. And before begin topic, what is the purpose of this Pig Latin? So handle semi-structured data as well, reduces MapReduce complexity and flexible schema handling. Pig is optimized for batch processing, not real-time queries. Data processing operators. This is another heading in the data loading and storage operator. So this is the way to load and use with alias, right? Without schema, load and give path and use that. Storing data, store process data using Pig storage, okay? Common storage. So these are the methodology given. You can use Pig any interactive like a scripting mode or grunt shell, this type of things you can use to do this, right? So what format we will get? Delimited text, Pig storage, like, okay, JSON, JavaScript, and Avro storage, Parquet, and ORC. I hope this is all clear with you all. So schema flexibility, custom delimiters, binary format, SC catalog. We use high table schema with SC catalog. Filtering data, removing unwanted rows early to optimize processing. And for that, this is the operator filter operators they mentioned out. You can go through and you can come to know what is that and how it is working. Comparison between filter and for each. So it's a row selection, for each a column transformation. Okay. And again, examples are listed out. Grouping and joining data in pig lighting. Inner joining, left outer joining. So these are the things given and replicated co-group operation. Create nested output structure with bags for each input relation. So this is given. So observe this. These are the methodology given. Then group operation, field based, expression based, group all, group any, and cross product. So join, co-group, and examples listed out. Sorting data in pig. So relation or unordered in pig. So dump store may output tuple in any order. So ordered operator, limit operator. So these are the examples just for practice. Then next topic is combining and splitting data in pig lighting. So union, and in that process is split. These are the process given. Then come. What is the union? What is the split? Combine relation, partition relation. Okay. Here union in merging and here preserving input. These are the. So here I'm stopping. This is all about pig lighting in Apache Pig, right? Thank you for watching.